The universe, a masterpiece of cosmic artistry. Galaxies spin like radiant pinwheels. Stars burn with unyielding brilliance, and nebulae swirl in a symphony of light and shadow. Yet, this vibrant expanse begins to dim. Galaxies drift further apart, their glow fading into an encroaching darkness. A haunting silence takes hold as the cosmos edges toward its inevitable fate. And so, the question looms. What happens when the universe as we know it ends? This is no ordinary mystery. It's the ultimate enigma, a story billions of years in the making, a journey into the future of everything, from the stars above to the particles that make us who we are. The universe's fate rests in a delicate balance of forces, the relentless pull of gravity, the enigmatic push of dark energy, and the cosmic dance of expansion and decay. Scientists have pieced together a series of theories, each as fascinating as it is unsettling. From a universe growing cold and lifeless in a heat death, to one collapsing into a fiery big crunch, to an apocalyptic big rip, these scenarios challenge our understanding of existence. Some even hint at a dramatic rebirth, a big bounce, or a quantum twist in a vacuum decay. Join us as we venture into these possible futures and uncover the strange and extraordinary ways the universe might meet its end. Heat death. Imagine a universe that never stops growing, stretching further and further apart with each passing second. This is the scenario of heat death, also known as the Big Freeze. Fueled by dark energy, an enigmatic force accelerating the expansion of the cosmos, galaxies are pulled farther away from each other, their light fading into the infinite void. Unlike gravity, which binds stars, planets, and galaxies together, dark energy does the opposite, pushing everything apart. Over billions of years, this relentless expansion ensures that galaxies become isolated, their connections severed by unimaginable distances. The universe cools, and the vibrant energy that once defined its youth dwindles. What remains is a vast expanse of emptiness, a cosmos moving ever closer to absolute zero. As the universe ages, its stars face an inevitable fate. They exhaust their nuclear fuel, growing dim and collapsing into white dwarfs, neutron stars, or black holes. Over trillions of years, even these remnants fade into cold, inert black dwarfs. Without stars to light up the cosmos, the night sky grows darker, and galaxies, now too far apart to interact, drift beyond the observable horizon. Black holes dominate the universe, their immense gravity consuming whatever matter remains. But even these titans are not eternal. Entropy, the gradual loss of usable energy, reaches its peak. The universe becomes a place of stillness, when only structures can form, no energy flows, and no processes occur. It is a slow march towards silence, where every last trace of activity grinds to a halt. Even the mighty black holes meet their end. Through a process called Hawking radiation, they slowly lose mass and energy over eons, eventually evaporating completely. What remains is a barren, featureless void, cold, dark, and devoid of life or structure. No galaxies, no stars, no atoms, just an expanse of infinite nothingness, hovering at the edge of absolute zero. This is the ultimate fate of a universe that expands forever, a somber reminder of the inexorable passage of time and the fragility of everything we hold dear in the grand cosmic tapestry. Big Crunch. Now, let's flip the cosmic script. Imagine a universe that doesn't expand into oblivion, but instead reverses course. This is the Big Crunch, a scenario where gravity becomes the dominant force, overpowering dark energy. The universe's expansion slows, halts, and begins to contract. Galaxies that once drifted apart now move closer together, like cosmic ships converging in a shrinking sea. As distances between stars and galaxies shrink, collisions become inevitable. Over billions of years, the entire universe compresses, growing hotter and denser. Eventually, the universe collapses into an unimaginably small and dense point, a singularity. This endpoint mirrors the conditions of the Big Bang, a concentrated state of extreme energy, matter, and heat, setting the stage for profound speculation about what comes next. As the universe contracts, temperatures skyrocket. The compression of matter and energy reignites nuclear fusion, briefly giving rise to new stars. The night sky, once dimming in the Big Freeze, bursts into a chaotic inferno of light and heat. But this resurgence is fleeting. The gravitational collapse intensifies, pulling everything closer and compressing it further. Galaxies collide and merge, stars burn out faster, and matter is shredded into fundamental particles under immense pressure. The universe enters a high-energy state, hotter and denser than anything imaginable. Eventually, all matter and energy collapse into a singularity, a point of infinite density where the known laws of physics break down. Here, time and space lose meaning, and the universe as we know it ceases to exist. But is the Big Crunch truly the end? Or could it be a new beginning? Some theories suggest that the singularity created by a Big Crunch could spark another Big Bang, triggering the birth of a new universe. In this cyclical model, the universe is not a one-time event, but an eternal cycle of birth, death, and rebirth, a cosmic heartbeat stretching across infinite time. If true, this means we might live in one iteration of an infinite series of universes, each with its own stars, galaxies, and possibilities. The idea challenges us to think beyond the boundaries of our current cosmos, connecting us to a greater, perhaps eternal, cosmic rhythm. Big Rip. Imagine a universe where the very fabric of space is turned against itself, unraveling like a poorly knit sweater. This is the Big Rip, a catastrophic scenario where dark energy doesn't just expand the universe, but accelerates so violently that it tears everything apart. Galaxies, once majestic islands in the cosmic ocean, are the first to fall victim. Pulled apart by the relentless stretching of space, their stars are scattered like leaves in a storm. The process doesn't stop there. Dark energy continues its inexorable acceleration, tearing stars from planets, planets from molecules, and molecules from atoms. A universe unraveling before our eyes, as every structure, from the largest galaxy to the tiniest particle, succumbs to the ultimate cosmic upheaval. As the Big Rip progresses, even the strongest forces in nature are no match for the power of dark energy. Stars are shredded, leaving behind a universe populated only by the remnants of their destruction. Planets crumble, their materials scattered as space itself expands faster than the speed of light. Soon, molecular bonds, the glue holding matter together, snap under the relentless strain. The very atoms that compose everything in existence are torn apart into subatomic particles. Space stretches infinitely, leaving nothing but an expanding void. In the aftermath of the Big Rip, there is no matter, no light, no energy, only emptiness, a silent, barren universe, where even the fundamental building blocks of existence are lost to the endless expansion. The Big Rip is perhaps the most unsettling of all end-of-universe scenarios. It's not a quiet fade into darkness or a dramatic collapse. It's total annihilation, a self-destruction driven by the very force that once gave the universe its shape. reflect for a moment on the sheer terror of this idea. Everything we've ever known, the galaxies, the stars, the atoms in our bodies, ripped apart by an invisible force we can barely comprehend. The Big Rip isn't just the end of the universe, it's the end of everything. And yet even in this chilling vision, there's a strange beauty. A reminder that the universe is as fragile as it is vast, and that its mysteries will always outpace our understanding. Imagine the universe as a precarious house of cards, balanced delicately on the edge of a table. What if, with no warning, one of those cards shifted and the entire structure collapsed? This is the chilling premise of vacuum decay, a scenario where our universe exists not in its most stable state, but in a false vacuum. Through a rare quantum tunneling event, a tiny bubble of true vacuum could form, a state of lower energy that the universe would naturally transition toward. This bubble, invisible and expanding at nearly the speed of light, would annihilate everything in its path. The bubble emerges, expanding relentlessly. Galaxies, stars, planets, and atoms are wiped out in an instant as the very fabric of space-time is rewritten. Within the bubble, the laws of physics as we know them no longer apply. Inside the bubble of true vacuum, reality itself would change. The constants and forces that govern the universe, like gravity and electromagnetism, could shift dramatically or disappear entirely. Matter and energy, unable to exist under the new conditions, would be obliterated. What's even more unsettling is the lack of warning. The bubble would expand faster than the speed of light, meaning its arrival would be sudden and undetectable. One moment, a star might be burning brightly. The next, it, and everything else, is gone. The universe as we know it would cease to exist, replaced by a new reality that we cannot comprehend. This isn't a slow fade or a violent collapse, it's instant annihilation on a cosmic scale. Vacuum decay forces us to confront the fragility of reality. What we think of as immutable, the laws of nature, the stability of matter, is ultimately built on an unstable foundation. It's a humbling reminder of how little control we have over the universe's grand design. Quantum events, random and unpredictable, could erase everything without warning. Yet there's also a strange beauty in this uncertainty. It underscores the preciousness of existence and the fleeting nature of everything we hold dear. In a universe where the ground beneath us could vanish in an instant, perhaps the most meaningful thing we can do is marvel at the present, finding wonder in the improbable fact that we are here, living and questioning the cosmos. Big bounce. Imagine a universe that doesn't have a beginning or an end, but instead exists in an eternal cycle of birth, death, and rebirth. This is the idea behind the Big Bounce, a theory where the universe contracts into a dense singularity, only to explode outward again in a new Big Bang, restarting the cosmic clock. As the universe contracts, galaxies collide, stars merge, and temperatures skyrocket. Matter compresses into an infinitely dense state, leading to a big crunch. But instead of a final collapse, this intense compression triggers another expansion, unleashing the energy for a new universe to form. A dramatic implosion pulling everything together, followed by an explosion of light and matter as a new universe emerges. Each bounce creates a new cosmic chapter, reshaping stars, galaxies, and potentially life itself. The Big Bounce offers a rare sense of optimism in the story of the universe's end. Unlike the finality of the Big Freeze or the destruction of the Big Rip, this theory suggests that the cosmos is resilient, constantly reinventing itself. If true, it means the universe never truly dies. It evolves. The atoms that make up everything today might reassemble into stars, planets, and even new forms of life in future cycles. Each bounce is an opportunity for new possibilities, a reminder that even in collapse, there is the potential for renewal. The Big Bounce challenges us to see endings not as final, but as beginnings in disguise. It's a story of resilience on the grandest scale, where the universe itself demonstrates that no matter how many times it falls, it will rise again. In the infinite rhythm of the cosmos, the Big Bounce reminds us that destruction and creation are forever intertwined, offering hope that even the end is not the end. As the universe marches toward its ultimate fate, the signs will be unmistakable. Stars, once vibrant beacons of light, will dim and fade as they exhaust their fuel. leaving behind black dwarfs, neutron stars, and black holes. Galaxies, driven apart by relentless cosmic expansion, will become isolated, their light drifting beyond the observable horizon. Black holes, the last dominant structures, will devour the remnants of matter before slowly evaporating through Hawking radiation. The once luminous universe will descend into darkness, a vast, empty expanse hovering near absolute zero, where time itself seems to stand still. In contemplating the universe's end, we are reminded of our place within it. Though fleeting, our existence is extraordinary, a rare window to observe, explore, and understand the cosmos. By studying the end of everything, we gain perspective on the value of the present, urging us to cherish the wonders of the universe while they endure. If the universe ends, what might rise from its ashes?